Right, show that the sum of 4r minus 5, starting at 1, ends at n squared, must equal n squared brackets 2n squared and minus 3. Okay, so it's going to be the sum of r equals 1, n squared, 4r minus 5. I like to always split these up into these component terms. This one here I'm going to deal with 4r, and this one here I'm going to deal with my negative 5. Okay, my 4r is 4 lots of the sum between 1 and n squared of just r. Because that's just r, you're not given this formula, you've got to remember it. And that's one which is half times n, which in this case is n squared. And then it's times n plus 1, because n squared is n, so it's going to be n squared plus 1. Okay, and I've got this 4 times. I'm just going to expand the brackets. I'm going to expand these two first to make it 2. I'm going to expand the right hand side, so it's n squared times n squared, which is n to the power of 4. And then I'm doing n squared plus 1, which is plus n squared. I'm going to expand this bracket again, just to give me 2n to the power of 4 plus 2n squared. Okay. Now, done all this, I've got to consider my right hand side. It's minus 5, but it is n squared, so this is just minus 5n squared. I'll bring that down to my equation, minus 5n squared. I've got n squares and n squares that I need to put together. Minus 5 plus 2 is minus 3n squared. And I say just 2n to the power of 4. If we remind ourselves of the question, it was this one here. They look similar, but this one here is obviously factored n squared out, which I can do. So I'm going to factorise n squared out, and I'm going to call that 2n squared, because n squared times 2n squared is 2n4, minus 3, which is perfect.